So the first improvement, which is very, very nice, is to have this one-way fluid structure interaction. So fluid structure interaction, I guess you know what it is. It's the interaction between fluid flow and structure analysis. So basically midas NFX has always been an all-in-one interface, so all the analysis in one software. But let's say CFD and structural were not so much linked together up to now. So right now we decided to integrate both together. So the first step will be is this one-way FSI that has already been developed in this NFX 2015. The second step will be the fully coupled fluid structure interaction, and we'll come with that probably next year for the next release. So it's quite simple actually. Before we had this feature, you could already took the pressure and the boundary condition from the CFD analysis and apply it to the structures through Excel, copy-paste, and this kind of operation. Right now you don't need to do all that. It's much more simple. The only thing you have to do is create an FSI interface, which is a bit like a contact, so it's working like a contact. You create the interface between the CFD boundary and the structure boundary, and you can exchange through this interface several types of data. So basically pressure data, shear force, and heat transfer. And in heat transfer you have the choice between transferring the temperature, the heat flux or the film coefficient. Actually in midas NFX CFD we have already fully coupled thermal and fluid analysis, but right now it was not coupled with the structure analysis itself. So right now what you can do is take these thermal results you get from CFD and transmit them directly to the structure to analyze the stress deformation due to the thermal CFD conditions. And all that can be analyzed in transient state. So this is what the interface looks like. So you have FSI type of analysis case that have been created. It's actually very simple to set up. You just have to set up separately CFD analysis like you would do for any CFD analysis, and then structural analysis, and you can link them together in this FSI analysis case. So you have the choice between steady-state CFD and nonlinear static or nonlinear quasi-static, or you can link together transient state CFD with nonlinear implicit dynamic analysis, for example. So this is possible as well, or with thermal types of analysis.